Hi, in this video we will give a layman introduction to AI and computer vision. Okay, we are familiar with AI, but why computer vision? Computer vision is an important application in AI, and thus it will be important for us to really understand how AI works in real world. Okay, let's begin. So we understand that artificial intelligence is driving a revolution in the world right now. However, the term AI is often used loosely, and because many people interact with AI tools like ChatGPT, we always hear that, oh, I know AI, but in fact, most people only know how to operate AI tools. To understand AI truly, we need to look beneath the surface to understand what are the mechanisms behind how AI works. In this video, we aim to demystify AI and one of the most fascinating applications of AI, computer vision. And computer vision is the field that enables a machine to actually see the world in their own way. So what is artificial intelligence? It is the broad field of computer science dedicated to making machines think and act intelligently in any way possible, not necessarily how humans do it, but in any way possible to achieve similar results. There's a misconception among AI learners that AI is just machine learning and deep learning, but that is simply not true. AI evolved earlier than machine learning, a couple of decades earlier, and started as a rule-based or search-based learning systems. And machine learning only comes about later when scientists discover algorithms that can make use of data to make models learn intelligently. And deep learning comes about even later during the internet age, where there's a huge store of information, and deep learning can make use of this vast reservoir of data to make even more complex decision and reasoning. And one of the applications we see today built on deep learning is ChatGPT. Now looking at the rule-based AI that evolved earlier, before machine learning. Okay, one of the algorithm is called the Dijkstra's algorithm. Dijkstra's algorithm, which is a breadth first search algorithm, tracing the path from a origin to a destination. So it's a path searching AI. So in this case, you can see that if we put our map on a grid, the fastest path from the origin to destination is the L-shaped graph, because the one represents the wall. Okay, and for Dijkstra algorithm, it expands radially. It's a AI algorithms that expands radially like this. Okay, and once it actually founds the destination, which is 15, it traces the least cost path back to the origin, and hence we see that this is our path to the destination. So even without using machine learning, we can simply use a search-based algorithm, a rules-based algorithm that enable decisions to be made intelligently. Next, A-star algorithm. A-star algorithm is a advancement from the Dijkstra algorithm because we make use of the heuristic map, which basically means that we know firsthand where the destination will be. What is the direction of the destination? So it adds on a heuristic cost map to our search, and hence it allows the expansion to be done efficiently without expanding into unnecessary spaces. So these two algorithms are one of the rule-based algorithm without using machine learning. Next, what is machine learning? Okay, machine learning is the next hierarchical subfield of AI. It's about teaching a computer using a learning algorithm. Previously, in the rule-based and search-based algorithm, we use a rules-based algorithm. But machine learning uses a learning algorithm to find patterns and make predictions from data. We mix of data and find a pattern in the data when we train on the model, okay, without explicitly programming the rules manually. So the model itself, using the data, will actually compute the rules itself automatically for us. And then there are main kinds of machine learning. They are supervised learning, basically learning from labeled data. Unsupervised learning, finding the patterns in data without labels. And reinforcement learning. Reinforcement learning that learn from trial and error, okay, to determine what are the series of actions to take to achieve a certain task. But more of the most common machine learning application is supervised learning, and that is what is our focus today. What is one very intuitive supervised learning machine learning algorithm? Is the k nearest neighbor algorithm, simply known as the KNN. Now, looking at a data set such as the fruits data set consisting of apple, lemon, orange, and mandarin orange, the k nearest algorithm can take in a tabular data. This is a tabular data, meaning data in a table like Excel. So where we have different features. These are the features. Okay, so for example, we look at the fruits like, for example, apple, because our eye see there's red. So red is a feature that makes us decide, oh, it's an apple. And we see a lemon is yellow, right? So in terms of tabular data, in terms of like in a table, we look at different features such as mass, width, height, for the computer algorithm to decide, okay, this is a apple. Okay, so then the fruit label itself is our target, where the machine learning model, the KN model, will feed the features to the target during training. So how does the KNN algorithm works? So for instance, if there is only one nearest neighbor, okay, and we can superimpose all our training data set onto a dimensional space. In this case, we consider just a two-dimensional space for ease of visualization. And k nearest neighbors looks like this. After we superimpose all the training points, these are all the training points onto this dimensional space, during testing of unseen data, okay, a machine learning algorithm, why is it important is when we use unseen data. For instance, if there's a new fruit and it lands on this particular point, the nearest neighbor is the apple, okay, because it's nearest in distance to the apple. And here we see a very simple machine learning algorithm that learns effectively, because we all know that fruits belong to the same type when they are similar in features to one another, right? That's how KNN works. It's a simple algorithm, but nonetheless is a machine learning one. Well, so machine learning is as simple as that, but of course there are more complex or mathematically involved algorithms like random forests, support vector machines, but there is a story for another day. Now, before we continue our foray into deep learning, even deeper hierarchical subfield of AI, we now turn our attention to computer vision, and let's put AI into perspective in this applied field of computer vision. So what is computer vision? Okay, it is what it works with what the computer sees. Okay, basically it works with the manipulation of images and videos. So anything that manipulates images and videos in a digital format, we say that is part of the field of computer visions. And some simple techniques, okay, in computer vision involve blurring or filtering image. And there are many other techniques. But computer vision becomes an applied field of AI when these techniques are paired with AI technologies to generate information out of these images and videos. Okay. So next, we ask ourselves, what is the data in computer vision? Previously, we see in the fruits data set, our data is in a table format. It's a tabular format. But for data in computer vision, okay, each data, for instance, it can be stored as JPEG format or PNG. Okay, each image is represented by a three-dimensional matrix of RGB channels, where each pixel here, okay, each pixel here is an integer between 0 to 255. Okay, because of this format of image data, we call an image an unstructured data. Okay, in the tabular data, we call it a structured data. But for image or even other fields of AI like natural language processing, text are considered unstructured data because they do not express themselves as a table format. Now we look at one operation in computer vision, which is the convolution operation. It's a very important operation. In fact, it's related to AI. Okay, it's the convolution operation, and convolution is basically a sum product of a filter matrix with the image. Okay, in a stepwise striding manner. So let's consider we have a filter like this. Okay, what is a filter trying to do? A filter superimposes itself on the image directly, and we actually compute a value of an element in the resulting matrix itself, and it moves in a striding manner. Where the next matrix convolution moves to the right, and until it creates a new matrix after the convolution. But now, why is this important? Let us see. Okay, a simple convolution operation, in the key intuition is that the process is a dot product between the filter and the sliding window. And if we know the dot product, it is actually an operation between two vectors. Now we flatten the filter and the sliding window into a single vector, and when we do a dot product between them, it measures the similarity or cosine similarity of unit vectors, okay, between the filter and sliding window. So this is the formula for dot product. Okay, now this is what we compute in the convolution, but another form of the dot product is this, and is this expression where cosine, is in between -1 and 1. So a bigger value represents a greater degree of similarity between them. For example, cosine 0 is 1, meaning these two vectors are basically pointing in the same direction, are basically the same. So a larger value represents a higher degree of match between the feature map of the filter and that of the sliding window. Okay, that's why a filter is called as such, because it's used to highlight regions of the image similar to the filter. Okay, now one simple AI application using this convolution operation is called the template matching. Okay, without machine learning, AI can also be used in CV, through the use of template matching. Now suppose we have an image from the book Where is Waldo, from Where is the Waldo's book, like this. Okay, we can extract the solution image of Waldo, which is how Waldo looks like, and treat it as a filter. Now, when we perform the convolution between this template image, which is our Waldo, and as our filter, and the image is come from, we obtain a correlation map between where the maximum tells us where Waldo is most likely to be located, which is here. Okay, this is Waldo. Okay, we see the most bright point. Okay, so recall earlier we say that a dot product actually finds the degree of similarity between the filter matrix as well as the the image that we want to do the convolution on. Now let's move on to deep learning for computer vision. Okay, apart from just simple AI application, CV can become much more powerful when paired with deep learning. But what is deep learning? Okay, deep learning is machine learning using neural networks. Okay, machine learning neural networks that can compute, okay, much more complex and richer relation between in the data. Okay, and the structure of the deep learning or neural network is layers of linear regression stacked on top of one another like this. Okay, so you have this hidden layer. Okay, a deep learning, why is we call it deep learning is because this neural network can become many layers deep, and the deeper a neural network goes, the more powerful a neural network can become. And each of these neuron, we call it neuron, actually computes a linear regression with a non-linear activation operation. So why is this? Why do we want to stack up these different hidden layers in neural networks? Okay, now if we see that the input layer, okay, represent the features we saw earlier in the KNN algorithm, like for example, earlier, like one of these are all the features. These are all the features, and in the earlier KNN algorithm, we have things like widths, size, and height. Okay. Now, if we use this change example, we use the apartment price prediction example, and use our neural network to make prediction on the price here. Okay. The subsequent layers represent more refined features. Like for example, if you have size and number of bedrooms, okay, the next layer may compute something called, okay, what's the family size that this apartment is looking at. Okay, this make the neural networks much more complex and more powerful in learning hidden patterns in data. Now, deep learning for computer vision, okay, shines in the scenario where, okay, it's applied to unstructured data. Okay, deep learning is very flexible when we apply it to unstructured data like images, graph data, or even like sequential data like text. Okay, and also it also shines where there's a big data. So because deep learning neural networks are very complex, when there's a lot of data, it can extract out more patterns, more important patterns to make more complex decisions. That there's a limitation of our traditional ML algorithm because the algorithm is simpler and thus may not be able to capture important structure in our data itself. So an image can have large dimension, okay, and each pixel in an image is like a feature column we seen in our structured data. So even for a small image of dimension 224 times 224 times 3, we already have astronomical number of features, and that makes it difficult to compute. Okay, if we were to apply our KNN to images, we will need to impose these data points on this amount of dimensions, which is very highly impractical for us to compute. And hence, there's a new particular neural network, we can use for our computer vision application, which is the convolutional neural networks. Okay, because the image contains astronomical amount of features, okay, we can use convolutional neural networks. And of course, it's similar to what we saw just now in the convolution operation. Okay, a convolution neural network is different from the vanilla neural network. Okay, in the vanilla neural network, the input vector is a flattened vector. Okay, like a flattened vector that we see. Okay, and at every layer, we are just at every layer, in every hidden layer, we are just computing a new refined vector. But on the other hand, for CNN, the input layer itself, okay, is the image, is the RGB image itself. And every layer, every next hidden layer we're computing is a new refined matrix of a different dimension. Okay, so a vanilla neural network works with like flattened vectors, but whereas for a convolution neural network, okay, and on every layer we are dealing with a tensor or matrix itself. Now a new refined matrix is obtained by repeated convolution with multiple filters. Okay, for instance, like initially we have this image data, right? So after one convolution with similar channel 3D filter, we obtain a slice, a matrix here, and then with more 3D filter itself, we compute even more slice that we stack on top of each other. So imagine we could have, like, for example, 64 3D filters, and then our output after the convolution layers, we would have 64 channels. Okay, and the idea behind CNN is, instead of handcrafting this filter, so earlier we saw that we want to find Waldo, right? We need to handcraft the filter to find where's Waldo. But then we learn the values of this filter, okay, in CNN by a process called backpropagation. And that is very very useful, because if the image is a cat or a dog, okay, training the CNN will be akin, okay, to adjusting these filter values. Okay, one particular filter might be to automatically detect whether the ear of the animal is either a sharp tip or a round tip. So one particular filter may want to detect the sharp tip of a cat, to differentiate whether, okay, that is not a dog, because a dog is a round tip, right? Okay, so we have covered an introduction to AI and computer vision, and how these technologies are useful. Okay, AI is a fascinating and rapidly evolving field, and the algorithms we covered in this primer, A-star search, KNN, CNN, okay, are just some of the many algorithms, okay, in this huge field of AI. Okay, even in this diagram itself, these are only the main branches of algorithms, and then there are many sub-algorithms, so many things that we need to learn. And apart from learning AI at a very high level, we also need to go deep down into the mathematical formulation, the coding, to fully understand what AI is about. So I will leave you here right now, and in the future we'll cover deeper into AI, the algorithms. So till then, let's continue our journey into learning about AI. Bye.